All right, so let's go to the training. Actually, let's just start with the introduction. Now, as you are already aware of WebLogic application server, I'm not gonna bother about much of basic, but I'm gonna talk to you about the very much very sensitive item in WebLogic. Okay, so first thing is like first as a person who deals with application server, you need to understand what is a web server and what is an application server. So that's the first important things which you need to know as application server administrator. Now, what makes a web server and what makes an application server, and why do we need an application server? And even though if it's an application server is required, and you have an application server, but still, why do you need a web server? So that's what we're gonna find it out on this particular topic. Um, Now, first thing is like you have the web server over here. And now, can you tell me any example of a web server? Apache. So Apache is the name of a company. Apache is not a service. Only the HTTPD is a service, and that is a HTTPD server, and it's a type of a web server. And can you name another one? There are many in the market, like for example, IBM HTTP server. Then you have iPlanet, and then you have Light HTTP server. Yeah, you have Oracle HTTP also, which is okay. So here in the application server, can you name some of the application servers which you are aware of? WebLogic is from Oracle. WebSphere is from IBM. Then you have what is ShapeOS is from Red Hat. It's kind of popular nowadays because it's very cheap when you compare it with WebLogic and WebSphere. Um, yeah, so it's kind of popular nowadays. So anything else? So Apache, Tomcat. So these are some of them, and then you have Glass Vision, all those things. So we're not included. It's not really important for our training. So Apache Tomcat is not a complete application server, but it's a partial application server, you could say, because it has it doesn't work with enterprise applications. Only it will work with the web applications. All right. So that's when we come to a conclusion that it is not a full-time application server, but it's a kind of a partial one. But other than Apache Tomcat, everything else we're going to discuss right now is going to be a full-time application server, and they are going to serve both the enterprise and the web content as well. Okay, so now let's see what makes it as a web server, what makes it as an application server, and what makes web server free of cost, and what makes application server an enterprise service. Um, right, so web servers are basically like serves two different protocols. Serves like um, HTTP and the HTTPS. So these are the two protocols which the web servers would work on. Now web servers, I would like to include IIS here as web servers because web servers are basically, it really doesn't matter if it's from a Windows platform or from a Unix platform. Web servers are web servers no matter how you host it. There are even connectivities between IIS and WebSphere or WebLogic is also there. There are connectivities like Apache, HTTP server, and WebLogic. That is also possible. There are different combinations. You can make this web servers and web application servers connect together. Now, first thing we're gonna see is like web servers are going to serve HTTP and HTTPS request. Web servers nowadays they can even serve. I've read in some of the topics like web servers can serve JSP contents, but it is not quite stable when it does that. um, there is a lot of problems while it serves a couple of other modules. Because what web server basically does is like, web servers are applications which is used to um, how do I say, which use like host application, host HTML files or any static pages. Okay, so what web server does is like simply host the file. So it just tells the browser that okay, if anyone is looking for me, I'm here. So it doesn't have any background processing or anything like that. So what it does is like there is a simple document root here which says the location of the application where the HTMLs and static files are sitting. So basically, when a web browser hits a URL, so it goes to the server, the load balancer. The load balancer will route the request to the web server. So once the web server gets a request, it will check the http.conf file for the details on which server name is going to be this, and then based on the request, it's going to go route it to that application. All right, so it's as simple as that, and there is no complication here. So once it goes to the document root, the content will be available in the document root as HTML or a JPEG file, it could be anything. So it just fetches that file and it gives the browser. Now browser here does the processing. Browser does the processing of HTML files, and it will browser itself will turn the HTML file to somewhat readable format. Okay, so here the role of the web server is just to simply pass on the information to the browser, and browser does the work of processing the HTML file. So it's very easy for the browser to process an HTML file because it's basically a text file without any knowledge of any compilation is required for the browser. You just have to check the HTML tags and the head tag and the body tag, and then it just put this aligned to the H1 or H2, or how much ever you highlight the particular font. So it's just going to do that. So it's very easy task for the browser as well. Okay, do you understand this? So web servers are basically there or probably available for the simple reason of hosting files on the web servers, and a browser will download that, and it will process it and it will show it on the browser. So that's all about the web servers. And the application server, on the other hand, has a lot of work to be done in the background. It is not just for just hosting a file, but also application servers are used for like application servers here are used for processing, compiling, and also you can say like it also works in different protocols. Like from what I'm aware of, like it works on HTTP, HTTPS, and then it works on IOP, and it works on RPC protocols. So there are many protocols here which comes into existence when you talk about application servers. All right. So application servers deals with all these protocols. But not just that, it also processes and compiles the data. So it doesn't give out data just like that or without any processing, because normally browser does not know about application server content because it's all about business logics. You know that, right? So even a small JSP file, for example, requires a compilation before it goes on the browser. Okay, so now this is where application server gets complicated here, because there are a lot of references to I would say to a lot of resources. For example, just a JPEG, a JSP file will have references to a couple of chart files. In turn, it will have references to a couple of JNTIs. The JNTI would in turn refer to some of the JDBC or JMS connections, which in turn requires a JMS server to be present, or a database server to be present for it to process the request, to understand what the request is all about. So all these complications are there in application server, which makes it like a separate application to process all these things and then give the exact output what the browser really requires, or probably the client what they need. Okay, so this is the major difference between application server and the web server. Do you understand what application has to go through? So why do we need an web server? So I just put this question over here because it's kind of relevant to ask from the application side. Um, so basically, if you understand it correctly, application server can deal with both the web content, or you can call it as web container, and also it can deal with application or enterprise container. So in this case, my application server can act itself as a web server who serves the web content like small HTML files to JPEG images, and also it can contain, it can also does application work like enterprise, like dealing with complex EJB files, business logic, web services. So why can't we use this application on a full scale than having a web server, which is a free component? Uh, so why do you have to do that? So why do you have web server at all? Any idea why we need that? Yes, why we need a separate web server component when you have an application server? Because if you want to have 4 servers, okay, okay, what's the use of using it as a proxy? We have a load balancer which will act as a proxy, right? So normally no one gets to know the IP address of anything. Even the web server IP is blocked by the load balancer because it goes to the load balancer first. Okay, so for example, you have 4 servers, 4 virtual servers. Nowadays, you don't find any physical servers there. It's all virtual right now. So you have 4 virtual servers available to you, and all they're asking you to do is like the client is asking you to make sure that you use these 4 servers to the fullest, to the maximum, and give them an application which can, where there can be no downtime first. No downtime, first reason. Second reason would be like the servers are the performance oriented. Yeah, the performance would be at the maximum. There should be no lag in the website, and it serves the client. All right, so the cost is not a factor because they are giving you 4 servers here, 4 virtual servers, which you'll have. If you want me to be very specific, they are giving you 8x core CPU with 16 GB of RAM each. So hard disk, it doesn't matter how much ever you want, you can take it. So this is a configuration they are willing to give you, and they want this no downtime and performance should be a top notch. So they are saying like I would getting like 100 requests per day. Okay, it's very small, I know that, but the performance should be the should be topmost. Yeah. So, the 100 requests sounds very silly. Say like we need 10,000 requests per day. That should be enough. Yeah. So take 10,000 requests needs to be served per day, and there should be no performance. And they're not telling you like at a point of time how many people will be browsing the website. So you never know how many people can hit the website at a point of time. So it could be like 100 users, 200 users at a point of time they will hit. So you have no idea. You have to do load testing for that. But assuming that this is what you want to get, what would be your conclusion here? Say for example, if you're going for a web server and an application server structure, so you divide 2x servers for web server and 2x for servers for application server. So this is how it's going to be. So what would you prefer 2x of web server and 2x of application server, or you want to change this, or you don't want web server at all? Instead of web server, you want to go for application server itself. Okay, so if it is not an internal one, it's an external one, what would you do? Okay. Mm-hmm. Um, can you tell me why? Why? That's the question here. See, okay. Okay, fine. Sounds good. So here I'll tell you the real reason for having a web server. Now, I would not go for this structure if you really ask me. I would go for 4x of web server and application server. Now I won't go for this as well. I'm sorry. I wanted to type something else. I would go for something like this. 2x of web server, 2x of application server, and here there will be application server as well. Okay. Yeah, correct. That's how it's gonna be. So why I do this is basically because um, I understand that we're gonna get 10,000 requests, and I know that there could be concurrent request as well. So the problem is like the application server will very much do well until there is no concurrent request. Okay, but the question is what if I get like 600 concurrent requests, like 700,000 concurrent requests? That becomes a question which I don't think my application server will be able to handle it, or even if there's like 1,700, 2,000 concurrent requests, if it's a public website, right? I'm not sure that 2,000 or 3,000, 4,000 it will not be able to handle. So what I'm trying to do is like I'm dividing my load here. So why do we have web server in the beginning is very simple to divide the load. So for example, I'm getting 200 concurrent requests currently, and I have only one application server to serve all the requests. All right. So what happens here right now is like I have one application server, which my application server can go maximum till 10 or 15, because if you say 200 concurrent requests, at least 100 requests would be for 100 requests would be for my static content, and 50 requests could be for some JSP files, and 50 requests would be for my database. All right. So maximum, if you see, there is only 20 DB to the max. They would have allowed concurrent requests to the DB would be 20, 15 or 20. That's the maximum. Okay. So the rest you can put it on the waiting, which will be like another 20 DB connections will be on the wait. Okay. Now, say for example, now the connection is coming in, 200 requests, concurrent requests are coming in, and I have one application server, which my application server will start processing the request for the static content, which will delay that 50 JSP file which is pending, and which will delay the 50 database file. Even though the static content retrieval is really fast, but I waste some time in retrieving a static content which can be done by someone else who can share the load of the static content. If I have a free stuff which can share the load of my static content, I can concentrate. I can make my paid stuff to concentrate on the real money part, where the JSPs and database interactions are there. That's when I get more money. Do you understand? So we can make that to happen by the paid stuff, whatever the application server I'm paying for, right? So in this case, 200 concurrent request. Yeah, say that. Um, it's very it's an internal process. You cannot see it. Even if you want to see it, you have to check the logs. You have to analyze the logs. There are a lot of log. Um, there are you just log processors are there. So you just put your log stuff, your access log into the log processor, and then you have to check. You can see like how many people have accessed your static content, and you can put the access log in your application server. In your application server also there is access log. Access log. Yep. Mm-hmm. Yep. 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 Yes. Okay. So in my workplace, you can say like what we do normally is like we have two types of deployments. One is static file deployment and one is EA file deployment. Okay, static file deployment is basically like if you have 10 web servers, right? All the 10 web servers will be having the common mount point. Okay, instead of putting it inside every server, we go to that NFS server and we put it there. Okay, so in turn which is applicable for all the web servers under it. Or if you want to put one particular web servers dedicated website, so we put it under that folder. So web server doesn't require restart every time you paste a content. Okay, it will work with the just like that, because it's not going to process anything, right? Yeah, but application server requires a restart in case if you're putting any Java related stuff. If you're putting web related stuff, it also doesn't require any restart. Okay, so now what I'm going to do is like I want to divide this to one web server, one application server. Now I'm going to get 200 concurrent requests. Now here there is a filter in the web server which checks all the 200 requests. Okay, and it will serve all the 100 requests, and it will filter all the 100 requests to the application server. Yes, it does an internal redirection to the cluster we have configured under the plugin. Okay, so the application server will receive the request from the web service, and then it will process the request, and it will divide 50 for JSPs and 50 for DB. So now we can see that application server is dedicatedly working on 100 requests rather than working on 200 requests. At the same time, 100 requests is being served by the web server to the application, to the people who is actually requesting the web pages, the static pages like JPEG image or anything like that. Load testing. Load testing. Load testing. Yep. That you cannot determine actually. That's pretty hard to determine, the static and dynamic pages. but you know, right? So when you call a web page, say for example, you're going to yahoo.com, right? So you see static page, dynamic page in the front page. Yes, of course, everything will be static because they want to load the content really fast. But when you log in, it goes to dynamic page. Okay, and that's when the logic is involved. When that's when the application server is needed there. Okay, so that's how we can determine how many people use. Basically, if you see, that's why you have two web servers in your environment because they know once you hit the website, it will go to the static page only. Okay, so that's the difference, and that's why we need a separate web server and an application server. And even if you have them, you have to make sure that two web servers are working in terms of balancing your load for only for the static pages. And there are multiple application servers. That doesn't matter how many application servers you have. It depends on how big your application is. Yep, web server. Yep. Yes, yes. See, if you're paying some amount for a specific stuff, you have to use that, right? Yeah. And also you have to use it for the right purpose. Yeah, I've seen in one of my companies I've worked, they've been using application service for a static content delivery. They brought the application server, but there is no use of doing that, correct? And now I understand that it's kind of idiotic to get an application server for serving a static content. Okay, so it happens like that. Some people buy it and then they don't use it for the right purpose. So it's not an offense. It still will be usable, but the problem is like application server takes a lot of time to come up to be available. Okay, but if you see web service, it will be started up in a seconds, in milliseconds to be very precise. It's because of the lightweighted. You can also configure web service in such a way that we can fine tune web service actually. You can fine tune a lot of things in web service that it doesn't consume a lot of memory at all. Okay, so even you can, I said you're right. There are people who uses JSP in web service. That is also possible, but it's going to take a lot of memory out of you. Okay, it's going to take a lot of memory that like just like application server because JSP is a thing where it requires to be processed by the web server itself, and web server is not good in processing contents. Yeah. So when we talk about IIS here, IIS is an Internet Information Service which is working only, which will work only on Windows platform. Yeah. So is a web server, and IIS is used for serving the same thing as the web servers, Apache HTTPD. In our training course, we're gonna see Apache HTTPD server. We're gonna see the introduction to it, like what are the version changes, what are the updates, like concept like dynamically shared objects, multiple processing modules. We have some prefab and worker. So we will be seeing that, and also we will be seeing the different methods of installation overview on that. And then we will be using binary method of installation for our program, and we will be configuring. We will be seeing multiple virtual hosts like name-based, IP-based, port number-based virtual host, and yes. So once we have seen those things, we will configure a website on the Apache HTTPD server, and we will be integrating with the application server and serving the request. So we will be seeing standalone and also cluster based. Okay. So in cluster we won't be seeing multicasting. Multicasting we won't be seeing because multicasting requires a dedicated hardware, which unfortunately with hardware. Okay, it requires a load balancer like multicasting hardware, which needs to be present and connected to the server. Okay, so we will be using unicasting method of clustering in our training program, and I'll be telling you how you can implement multi-casting clustering once you have the hardware. Yeah, in your servers you can try, I believe. Do you have the hardware? Okay, that's good. No, we cannot do that. You need a hardware for that, multicasting hardware. Hardware, hardware, yeah. Yeah, it's kind of a load balancer. But what happens in multicasting is like the difference between unicasting and multicasting is like unicasting works on single port number. Say like it's like a one-to-one connection. So you are there and I'm connecting to you through Skype, correct? So you and me can talk right now, correct? But multicasting is like YouTube Live. Have you heard about YouTube Live? Yeah, so I can broadcast this whatever the video which you're seeing, I can broadcast to YouTube Live. So once you it's there in the YouTube Live, people, a lot of people will be joining to the YouTube Live and they will be able to see the video which I'm broadcasting. All right. So we need a hardware like YouTube Live that is called multicasting hardware. Okay, so once I have the hardware, I can connect multiple clusters, multiple members of the cluster to that hardware, and the web server will be routed, web server will be pointing to that hardware. Okay, so whenever people access, they don't access the web server, but they don't access directly the application server. They will be accessing the cluster hardware, multicasting cluster hardware, and in turn, the multicasting cluster hardware will route the request to multiple people.